So should we do this? Or this? Looks sort of cool. Or this? Batman style. I think I like this. Let's do this. Petroleum, oil and gas, crude oil, mafuta, or whichever way you know it. Where did this substance come from? Like, you've never wondered? Like, come to think about it. The world as we have it today wouldn't be as we have it today or know it today without petroleum. Like, I would place a bit on that. Would it have been better? Maybe. I don't know. Would it have been worse? I highly doubt so. But whatever the case is, let's just agree the world of today is a world as we know it today because crude oil is existent. Now, if this substance has so much power to influence how we do things, isn't it just fair that we talk about where it came from? Let that be my job. Worry not. So where did petroleum come from? Well, let's start with the word petroleum itself. Now, petroleum is a combination of two words, petra and oleum. I don't know if that's the right pronunciation, but bear with me. Take it as I say, oleum. Now, petra is a Greek word for rock. Oleum is a Latin word for oil. So when you add petra and oleum together, you end up with petroleum, which in essence means rock oil. So up to this point, we can all agree petroleum comes from rocks. Now, if you don't believe it, just go with it. Petroleum comes from rocks, like it's picked out of the ground with a number of sophisticated processes and machines which get it out of the ground to the surface. Bear with me, take it. It comes from rocks. So at this point, we all agree it comes from rocks. But how did it end up in the rocks in the first place? Is there like a vast ocean of crude oil deep down there which just keeps seeping to the surface? Maybe we shall never be 100% sure, but there are two theories that suggest how oil ended up deep down in the ground. These two theories are the biogenic theory and the abiogenic theory. So let's start with the biogenic theory. Biogenic theory of petroleum says that petroleum comes from bio origins. In other words, petroleum comes from dead plants and animals. Now, you and I know that if plants and animals die and are preserved over time, they become fossils. That's the name fossil fuels. So oil from dead plants and animals is fossil fuels. So every time you're actually classifying oil, crude oil, in other words, as a fossil fuel, you are actually lining up behind the biogenic theory. Following? So what exactly happens? What exactly happens is that when plants and animals die, they have to be rapidly buried under anoxic conditions. Otherwise, oxygen will react on them and will end up destroying the organic matter. What we actually want is the organic matter. So it has to be buried very fast where there is no oxygen and preserved. Weirdly, even with the most suitable conditions, only about 1% of the organic matter is preserved. Now, we're talking about 1% of what? 1% of organisms like zooplanktons, planktons, phytoplanktons, such small organisms. So why are we talking about organisms like elephants, dinosaurs, man? And what happens is that the less advanced an organism is in the food chain, the more organic matter it has. In other words, algae, which is down in the food chain, has more organic matter than an elephant. Makes sense? So what happens to the organic matter? What happens to the organic matter is that through a number of processes like diagenesis and catagenesis, it is converted into a substance called kerogen. Now, kerogen is a sticky substance that with the right temperature, pressure, and time interval could give us oil, gas, or coal, also depending on the type of organic matter we had in the first place. Now, speaking of time interval, do you know how long it takes us to produce oil? It takes us about 100 million years on average. Now, you need to know though that the world uses about 36.5 billion barrels of oil per year. I mean, one single year you're using 36.5 billion barrels, but it's taking you hundreds of years to produce even a single barrel. What is that? That's why so many times you hear crude oil being categorized as a non-renewable energy resource, because it takes so much time for it to form only to be used up in no time. So yeah, that's actually one other thing that the biogenic theory says, that oil will eventually have to run out. Now let's just put a pause to this and go to the abiogenic theory. What does the abiogenic theory have to say? Now, abiogenic, note that there is an A in front of the biogenic. Let that A stand for probably anti-biogenic or against biogenic, whichever way you want to interpret it, but anyhow, it disagrees with the biogenic theory. In other words, actually this theory though came before the biogenic theory. It's the earliest theory. Now this theory does not believe that oil comes from organic origins. It says that oil comes from inorganic origins. So where does it come from, Mr. Abiogenic theory? This theory says that on the lower part of the mantle, there are carbons, and these carbons go through a number of processes to release hydrocarbons. Now, hydrocarbons are, in essence, crude oil. So every time you hear hydrocarbons, let what runs to your mind be crude oil. Hydrocarbons make the biggest composition of crude oil. So, and according to this theory, oil finds its way to the surface through seeping through fault zones. It tries to find its way to the surface. At this point, this is where actually most of the disparities start, because now it has been proven that most of the fault zones, most of the oil we have around the world is not found in fault zones. Now, if the abiogenic theory argues that oil finds its way to the surface through fault zones, how come most of the oil we have is not associated with fault zones? And this is just a point of caution. It is not wise to drill in a fault line. If you think about drilling a fault line, who answer you? I mean, this article wouldn't say it any better. Yeah, that's bad. Reason why most people would have to rally behind the biogenic theory is, if oil will never run out and oil is finding its way into reservoirs through fault zones, you'd essentially expect these reservoirs that have been used up to refill, but we don't even have a single evidence of any reservoir around the world ever having to refill. So, we have question marks here though. So it's also been found that oil has something in it, some molecules which are very similar in composition to those that are found in living organisms. These are called biomarkers. So the argument usually is, if something is found in oil which is similar to what is in living organisms, the argument should be, or the conclusion rather should be, that this oil came from this living organism. But people from the abiogenic theory disagree with this, and for them, they explain this coincidence by saying that as oil is moving from the mantle to the surface, it comes into contact with the living organisms which feed on it, and they end up leaving their marks in the oil, thus biomarkers in the oil. How true is this? We shall totally never be able to know, but well, that's what they say. The other evidence that points to the biogenic theory is that over 90% of the world's oil reserves have been associated with sedimentary rocks. So there are three different kinds of rocks: igneous rocks, metamorphic rocks, and sedimentary rocks. Our interest is in the sedimentary rocks. So sedimentary rocks, these are kinds of rocks which are formed when there is deposition of sediments, and when they are compacted over time, they form rocks. Now, these end up giving us what they call sedimentary rocks. So in essence, these are literally the only kinds of rocks in which you'd expect to have organic matter. And these are the kinds of rocks which have been found to be associated with crude oil. So there is a correlation that if most of the oil is being found in sedimentary rocks, that means, or close sedimentary rocks, that means the oil could be coming from these kinds of rocks. But the biogenic theory also has something to say against this, because there have been found some reservoirs which have been found in igneous rocks. Igneous rocks are the kinds of rocks which come from volcanicity. In other words, rock coming from the mantle upwards to form volcanic mountains. But also there's a comeback to this, because they say most of the rocks that have been found, most of the oil that has been found in volcanic rocks is close to sedimentary rocks. So the argument is that the oil finds its way from sedimentary rocks through cracks and finds itself forming a reservoir to the igneous rocks. But people from the biogenic theory also have a point. I mean, it has been proven and found that planets like Jupiter, Uranus, Neptune, Saturn, and even the moons of Saturn have been found to have hydrocarbons, especially methane. Now, how do you explain the presence of hydrocarbons in these kinds of planets that have been proven not to have life? I mean, how? If you're saying oil is from living organisms, how do you explain that? I also need to add that there has been found some oil that correlates perfectly with the abiogenic theory. Unfortunately, this oil is not globally significant. Is it possible that one day we shall find some of these deposits in large amounts? Maybe, but as for now, we haven't found any. However, in the midst of all this mumbo jumbo, there is a German chemist called Detlev Moller. Not sure if that's the right pronunciation, but well, that name. He says though he did a study and he found out that it's actually possible for these two theories to coexist. Yes, oil could come from both the biogenic theory and the abiogenic theory, and they could be happening at the same time. For me, that sounds like good enough of a conclusion. Everyone wins. Biogenic, you are true. Abiogenic, you are true. But everyone is entitled to their opinion, and I would like to know which of the two theories makes more sense to you. Yes, it's true, most of the world scientists have rallied behind the biogenic theory, but you have a point to say. Okay? Well, someone is asking which theory I rally behind. Come on, I'm a scientist. I could be coming up with my own theory anytime from now. Just watch out. So thank you so much for watching my video. Don't forget to like, subscribe, and comment. Most importantly, share with all your peers. And see you in my next video. Bye bye.